All right, so 5.5 is negative exponents and scientific notation. So if you go to the PowerPoint and look at this is really um, a great slide that kind of reviews everything we've covered up to this point. Now this is kind of the new point down here, what we'd have to do with the negative exponent. So if we do have a negative exponent, basically I like to say it travels. So if we have remember we have two parts of a fraction. We have our numerator denominators. If we have a negative exponent in my numerator, it will move to the denominator and turn positive. If I have it in my denominator, it'll move to my numerator and turn positive. We'll just go through some basic examples of that. So if you see this A, and we're going to talk about what that negative sign in the front of it means. What that means is that's -1 times the exponent. So the -1 really just not going to do anything, but that negative exponent goes to the denominator. And like I said, the negative just kind of stays where it's at. But since that's negative, in your answers, you will never leave a negative exponent is what you got to get used to. And then just understanding the difference, since again, with this parentheses around the -3 and it's -3 to the -2 power, it moves. And again, you would actually have to solve -3 times -3 would give me 9. So know the difference between B and C. Okay, in B, like I said, this negative is kind of separate to this problem right here. It's like, I always like to say, it's a -1 times this. So you would solve this exponent first. So the exponent itself is 1/9 because the negative exponent moves to the denominator and then it becomes 9. All right, and then we apply the -1 to it. So that's why this one, know the difference. Why this is -1/9 and this is 1 over. You're gonna look at these and say, oh, they're exactly the same. Nope, the parentheses make a big difference. And this parentheses, since it's on that -3, it means -3 times -3, all right, to the -2. So first it moves down and then you solve it. This one is actually -1 times this. So this is actually +9, but then I'm multiplying the -1 to it. And let's just get into some examples so it'll make a little bit more sense to you. All right, so just like on some of those examples where we had a negative sign in front of it and I was telling you it was -1 times that, this is the same thing. This is really like -5 times this exponent. And so we have to deal with this. If you think of order of operations, we have to deal with this exponent first. And again, it's a negative. So all of these we kind of think of as fractions, all right? And the way you remove a negative exponent is you make it travel. If it's in your numerator, you move it down to the denominator. Once you move it down to the denominator, that exponent becomes positive. So don't forget, sometimes people move it and they keep it negative. When you move it, it stays positive. It becomes positive. And again, the -5, I don't have to move that. That just stays there. So if we clean this up, this is actually going to be -5 over x. Because remember, we're not going to put x to the 1 in our answer. And on number 2, I kind of want to write it the way they do it. All right, so they put that negative sign and it's kind of right in the middle of that fraction. So you don't know if that negative is on the 1 or on the 3. I always will move that negative to the 1. All right, so I'll make it kind of look like this. Where it was kind of in the middle, I'm going to move it up to my denominator. Okay, you can move it to the numerator if you want, but in my case, I'm going to move it up to the denominator. And then I got to apply that -3 to each of these. Remember, these are like 1s here. I'm doing -3 times 1, so that's going to give me -1 to the -3. -3 times 1 here, and this is going to be 3 to the -3. So I have negative exponents. I cannot leave negative exponents in my answer. So what I'm going to do is I'm going to take the -1 to the -3. I'm going to move it to my numerator. It's going to become -1 to the +3. Once you move it, it becomes positive. 3 to the -3, I'm going to move, it's on my denominator, so it's going to move up to my numerator. And when I move it to my numerator, it becomes positive. Okay, so if we're dealing with variables, I'd be pretty much done. But since I'm dealing with numbers, I got to know what these values equal. Okay, so 3 times 3 times 3, 3 times 3 is 9, 9 times 3 would give me 27. -1 times -1 times -1 actually gives me a -1. Okay, and this is just not simplified because I'm 27 divided by -1 would actually give me -27. So that's how you solve that one. Apply the -3, make those exponents positive, and then simplify. Just this one's not that hard. If you notice the negative exponents in my denominator, I can't leave negative exponents, so it would move up to my numerator and be p to the 6. Yes, technically there's a 1 underneath there, but we don't write that in. So it just becomes p to the +6. It moves up and becomes positive. All right, so we have a p to the -7 being divided by a q to the -4. So I can't combine these. These are different variables, p and q. Okay, but all I can do is make those exponents positive. So the p to the -7 is going to move to my denominator and become positive. And you can do whichever one first, it doesn't really matter. Q to the -4 would move up to my numerator. And that is a q. I don't like q's, but that's a q to the 4th. So I have q to the 4th over p to the 7th, and that's pretty much all I can do there. I am done. We're just going to keep doing examples dealing with these negative exponents. So we've had problems like 7 before. Okay, so I could apply that -3 both places. So -3 times 9 gives me x to the -27. And -3 times 7 gives me y to the -21. So again, I have negative exponents. So they need to travel. They need to move down to my denominator. When I move them down to my denominator, they become positive. Now, if you notice, there's nothing left up here. But there's always something there. Don't ever leave it just blank. And what should be up there is the 1. So it's 1 over x to the 27 and 1 over y to the 21. All right, so if you look at this problem, a lot of x's, but I can't really work into here till I know, I can't subtract anything or simplify anything till I do this first. And again, this is power to the power, so I would multiply 3 times 4 and give me x to the 12th over x to the 16th. All right, and now what happens is my rule is bases are the same, subtract top from the bottom. So 12 from 16, which would not be +4, it would give me a -4. So again, I can't leave my answer with a negative exponent. So I would have to move that down to my denominator and make it x to the 4th, and then put a 1 up on top in my numerator. So x to the -4th simplifies to 1 over x to the 4th. All right, a few more. Actually, this is my last example of these exponents. And then we're going to talk about scientific notation. All right. There's a few ways you can do this. We can simplify in here first, okay? And really order of operations says we should do that. So let's just go ahead and do that first. Okay, we're going to do inside these parentheses first. Again, bases are the same, so it's -4, take away 5, top minus the bottom, -4 minus 5 would give me negative 9. And then I would do 4. My y's are the same. 4 take away 6 would give me negative 2. Okay, now these are still in that parentheses and it's still being squared. So at this point, I would apply that 2 to both of these spots, which negative 2 times the 9 would give me x to the negative 18. Then negative 2 times 2 will give me y to the negative 4. And I got one more step, again, because I cannot leave my answer like this. If you enter this, it will say it's wrong. Cannot leave negative exponents in my answer. So again, both of these would have to travel to my denominator. Since there isn't a number here, or there's a number here, it's a 1. The 1 would stay up there. And again, don't forget, when you move these down, they become positive. That's I keep repeating that because that's the common mistake. People will move them down and keep the negative on there. When they travel, they become positive exponents. All right, so let's look at scientific notation. If you go to the PowerPoint, and actually before, there was a really good slide in here. Yeah, the one that reviews the summary of the exponents. Again, I think that is a really good slide. You know, this one's good too. This will kind of go over all these properties as well. But summary, this one right here. You know, again, it just kind of goes over, if you ever get really stuck with these rules, this is a great one that kind of explains them. It uses variables, but it's everything that we need to know. And there are some good examples in the PowerPoint. That's why I try to just go through some of the ones on the assignments. But scientific notation. All right, the first thing to understand, scientific notation is really used when you're dealing with numbers that are very large or numbers that are very small. Okay, and it's kind of the way we write either really big numbers or really small numbers. The first part to understand about scientific notation is your first number must be a number between 1 and 10. All right, so in other words, it can't be less than 1, it can't be a decimal, and it can't be a 2-digit number, which would be 10 or higher. So when you see these problems, and you got to figure out where you're moving your decimal has to be moved to the value of 1 to 10. That's that first step. And then you've got to count kind of how many times you had to move that decimal. And we'll talk about whether it's going to be positive or negative. So let's look at this example here. It's 4,700. Now, A compared to B, I hope you all would understand 4,700 is large compared to 0.00047. If we were talking miles or even feet, you're walking a lot more walking 4,700 feet as opposed to 0.00. I mean, this is not even close to one foot, okay? When you have smaller numbers, your exponent's going to be negative. When you have larger numbers, your exponent's going to be positive as far as, and we'll talk, you know, when we're talking about powers of 10. So if you look at 4,700, where does our decimal have to be? I have to move, I can put it, you know, here, you know what I'm talking about. So right now the decimal is right behind this 0. Okay, and if you look at B, you could see where the decimal is. On the larger number, the decimal sometimes isn't clearly noted because we don't just write a decimal there. But the decimal right now is here, and I have to move it. Where would I move it where it would be a number between 1 and 10? And they would be between the 4 and the 7. So I'm going to have to move it from here to 4, make it 4.7. So I'd start out with, you know, moving the decimal to 4.7. If you count, you're moving it 1, 2, 3 places. All right, so you'd write 4.7 times 10 to the third. Again, if it's a bigger number, it's going to become positive when you move it. And you also should be able to go from 4.7 times 10 to the third back to this. So you start with 4.7 and it's telling you you'd move it 3 places. and you would make it bigger since it's a positive. If it was a negative number, you know, it'd be like this. So again, even though this is a decimal, where I want to move it is the same. I want to move it to between the 4 and the 7 because it has to be a number between 1 and 10. So it has to go between the 4 and the 7. So we're going to count. I'm moving it 1, 2, 3, 4 places to get it between that 4 and the 7. And again, I am moving it. It's a decimal, so it's going to do a negative exponent. So it's 4.7 times 10 to the negative 4. And then again, it just talks about working backwards. If you start with this, 10 to the third means we're going to make it bigger. Okay, so it's going to go this way, 3 places. 6.45, since we're doing it to the 10 to the negative 5, that means we are going to make it smaller. So that means you're going to the left 5 places. And then sometimes you have to add zeros, okay? So here you had to add some zeros to move it 5 places because there wasn't any numbers there to move it. And then that's what it would look like. And we'll do some examples of those. But the PowerPoint was kind of a little easier to explain that. So if we have the number 56,000 and we want to write that in scientific notation. So again, what I was telling you is that decimal is right there. They won't really ever write that decimal in, but you just in a bigger number, that's where that decimal is going to be. And I want to move it, the decimal, to a number between 1 and 10. So where would that be? It'd be between the 5 and the 6. So I want to move it. I want to move it right there. So my answers, I already know, is going to be 5.6 times 10 to the whatever. So this is what I got to figure out. What is that power going to be? Well, first I know it's going to be positive because this is a big number. But how many places? How many? 10 to the what? So we count 1, 2, 3, 4. So it would go right there. 5.6 times 10 to the 4th. And I do want to show you something when you're entering these problems. I do want to show you how you have to enter these in the assignment. All right, so I just wanted to show you how we need to enter these problems. All right, so we already said the answer is going to be 5.6 times 10 to the 4th. So you're going to enter your 5.6. What you got to be careful not to do is to press the X, because I know it looks like, you know, X is our multiplication, but you have to use this multiplication sign here actually in the program. Okay, then you go 10 to the, I think, what was it, 4th power. All right, so just keep that in mind. Do not, if you press the X, it's going to think you're trying to write the variable X. So we want to make sure we don't do that. And we have another example. All right, so we know this is a smaller number. So in our minds, hopefully we know whatever our answer is going to be, it's going to be to a negative exponent. Because again, this is a smaller number. First thing you got to figure out is where do I need to write? Where do I want my decimal? Right, it's currently right here. And again, it needs to be between a number between 1 and 10. So again, if you put it here, 18 is not between 1 and 10. Right here, 1.8 is a number between 1 and 10. So I need to put it right there between the 1 and the 8. So if we count how many times we got to move it, we go 1, 2, 3, 4, 5. I had to move it 6 times. So it's 10 to the negative 6. And again, the number that it becomes is 1.86. And it's fine if it's, you know, there are going to be decimals. Okay, but it's 1.86 times 10 to the negative 6. And again, I just want to go in here and reinforce how you have to enter these answers. So it's 1.86, and we don't hit the X button. We have to use the times button down here, the multiplication sign down here. And then it's 10 to the -6. And then you're good. And let's look at, we'll do an example just from the, we're going to get a similar question to number 19. All right, so 6.8 times 10 to the -3rd. It's right here. Okay, again, is that going to make that number bigger or smaller? And the way you answer that is looking at that exponent here. That's a negative exponent. So 6.8 isn't going to get bigger. If it was positive, it would get bigger. So we know it's going to get smaller. How much smaller? I got to move it 3 places to the left. So we count 1, 2, 3. I'm going to move the decimal right here. And I don't see any numbers here. So what do I have to do? I have to add zeros there. Okay, so this is actually 0.0068. And that'd be the answer that you would enter. All right, so 5.5, negative exponents and scientific notation.